Hey guys, today's is a very exciting day. Today we are starting Unit 2, Absolute Value Equations and Functions. Now you should already know what an absolute value equation or function is, or what absolute value is. Absolute value is just the straight up and down lines that you see here. And it's pretty straightforward. Whenever you see these straight up and down lines, whatever it means is whatever is inside of those straight up and down lines, whenever you take it out of it, has to be positive. The reason is absolute value is a measure of a number's distance from 0. And negative 8's distance from 0 is 8. It is 8 spaces away from 0. That's what makes it always positive, because a distance cannot be negative. So, in other words, anything inside those field goals, whatever is inside there, whenever you take it out, has to be positive. So if we take a look here at like number 2, okay, this 17 already is positive. It's going to stay positive. It doesn't change. But this negative 17, whenever we take it out of the absolute value, it's going to change to a positive 17. Now you'll notice that that negative on the outside of my field goals did not change. Because it was on the outside, that negative is going to stay there. So then we're just going to have 17 minus 17 equals 0. So the answer for number 2 here is 0. Let's take a look at number 3. We can do operations while it's on the inside of those field goals. So 27 divided by negative 3 is a negative 9. And the absolute value of negative 9 is going to be a positive 9. Let's take a look here at number 4. Number 4, I have 2 negatives. I have a negative on the outside and a negative on the inside. Now the negative on the outside is not going to be affected by the absolute value, but the negative on the inside is. So whenever I change that negative 9 to positive, that negative on the outside is going to stay, but the negative on the inside is going to go away. So my answer is still, oddly enough, going to be negative. Take a look at number 5. It's kind of the same thing. That 4 on the inside isn't going to change. Because it is already positive. And that negative on the outside isn't going to change because it's on the outside of it. So that negative is going to stay. That 4 is going to stay a positive 4 because it's always positive what's on the inside. And so there's your answer, negative 4. Okay, try number 6 real quick. You can put that answer for number 6 in the video. So I'll give you a second to do that. Good. All right, so we have negative 5 times negative 7 is a positive 35. Is a positive 35, and the absolute value of positive 35 is going to stay 35. So the correct answer is 35. Awesome job, guys. All right, let's move on. And let's talk about how we can solve absolute value equations. Because absolute value equations are weird because a lot of times we can have 2 answers that solve for them. Let me give you an example here, okay? X, the absolute value of x equals 3. And so I want you to think, what could x be? Well, obviously, x could be 3, right? Because if x was 3, the absolute value of 3 is 3. However, x could also be equal to negative 3. If x were negative 3, it would still work. The absolute value of negative 3 is still 3. And so both of these are correct answers. Both of them work. Well, whenever we look here like on number 7, I have the absolute value of x minus 3 equals 24. Well, this whole thing, it could be equal to 24, but if negative 24 was inside of here, it would still work, right? If negative 24 was there, the absolute value of negative 24 is also 24. So in other words, x minus 3 could of course be equal to 24, or x minus 3 could equal negative 24. Both of these could be true. So we're almost always going to have two answers to each absolute value equation. So let's try to solve these, okay? Let's go ahead, let's add 3 to both sides. And so x equals 27. Let's also add 3 to both sides here. And so x equals negative 21. Now listen, both of these answers are just as valid. Because if we plugged either one of these in, it gives me the correct answer. It makes it equal. Let's prove that. One thing about absolute value solutions is that we have to check for extraneous solutions. Because sometimes in this situation we are shown answers that don't actually work. And you'll see some of those in a second. But let's plug both of these in. Let's plug in 27. Let's say the absolute value of 27 minus 3 equals 24. 27 minus 3 is 24. Does the absolute value of 24 equal 24? Yes. So this is a correct answer. Now let's try negative 21. What if we plugged in negative 21? Would that work? Let's see, negative 21 minus 3, the absolute value of that, does that equal 24? Well, negative 21 minus 3 is negative 24. Does the absolute value of negative 24 equal positive 24? Again, yes. So this is also a solution. So there is no extraneous solutions for this. Okay, let's go back and let's take a quick look at these 3 steps. Step 1, step 2, and step 3 to solving these. Our first step, we did not have to do for number 7 here. My first step is isolate the absolute value expression. Isolate the absolute value. So we want just the field goals on one side. It was already done for us on this one, so we're good. But step 2, drop the absolute value by rewriting as a disjunction. In other words, 2 equations. Remember, that's where you have 2 separate equations separated by an or. Okay? Now, we just split it up, and then we solve it just like I did here. And then step 3, we just solve. And then I'm going to say once again, remember to check for extraneous solutions. So let's jump to the back, and let's do one where I actually have to solve for my absolute value first. You'll notice this absolute value on number 8 is not by itself. So I'm going to have to get that absolute value by itself first. And to get it by itself first, I'm going to need to add 6 to both sides. Once I've added 6 to both sides, my 5x, the absolute value of 5x, is equal to negative 6. It's by itself. We have gotten my absolute value alone, so now I can drop it and write it as 5x equals negative 6, or 5x equals positive 6. And how do we solve this? Well, I'm just going to divide both sides by 5 and get x equals negative 6/5. Or, on this one, I'm also going to divide by 5 and get x equals positive 6/5. Now, those are my 2 answers. But we still need to check for extraneous solutions. So I'm going to take this negative 6/5 and I'm going to plug it back into my original equation to see if it works. Okay? So here I'm going to check for extraneous solutions. So I'm going to go absolute value of 5 times negative 6/5 minus 6 equals negative 12. All right, 5 times negative 6/5 is just negative 6. My 5 and my over 5 just cancel. So we just have the absolute value of negative 6 minus 6 equals negative 12. And it looks like it's going to work. At first glance, doesn't it? It looks like it's going to work. But the absolute value of negative 6 is a positive 6. Does 6 minus 6 equal negative 12? No, it equals 0. Hey, this one doesn't work. It doesn't check out. Let's try the other one. Let's take that 6/5 in and see if that works. I'm going to go over to this side and I'm going to say 5 times 6/5 minus 6. Does that equal negative 12? We're asking the question, does that equal negative 12? Well, 5 times 6/5 is 6 again. The absolute value of 6 minus 6, does that equal negative 12? No, right? It equals 0 again. So this one doesn't work either. Now let me explain to you why neither of these work after we solve. Look here. It's equal to a negative number. If an absolute value is equal to a negative number, this absolute value of 5x is equal to negative 6. Is there anything that I can plug into an absolute value to equal a negative? No, it is always positive. So on this particular problem, if you ever see an absolute value equal a negative, you know that your answer is going to be no solution. All right, I'm glad we got that out of the way. So there's our first no solution problem. Let's take a look here at number 9. Number 9, we have 2 times the absolute value of x minus 1 minus 4 equals 24. Now something you've been taught, distribute. Just distribute this too, right? Unfortunately, we cannot distribute into an absolute value. Okay? It does not work like a parentheses. Absolute value and parentheses are not the same thing. So we cannot distribute. We just solve for it. Okay? We're still trying to get that absolute value by itself. And to do that, I have to get rid of that too. Okay? So what it's going to look like instead is I'm going to start off by adding 4 to both sides. And so I'm going to have 2 times x minus 1 equals 28. Then I got to get rid of that too, because I cannot distribute into an absolute value. So we're still trying to get that absolute value by itself. And to do that, I'm going to divide both sides by 2. So we're going to get the absolute value of x minus 1 equals 28 divided by 2 is 14. So now I have my absolute value by itself, and so I can separate it up into 2 separate equations. All right? Let's check this out. We're going to go x minus 1 is equal to positive 14, or x minus 1 is equal to negative 14. So we're able to split it up, and since the absolute value is equal to a positive, I am going to have solutions for this one. Okay, so let's solve this. Let's add 1 to both sides. We're going to get x equals 15. Let's add 1 to both sides here. So x equals negative 13. Now guys, you always need to check for extraneous solutions, but sometimes we can just do it in our heads. Let's do that right here real quick. Here is my answer, x equals 15 or x equals negative 13. Let's try them out. If I plugged 15 back into my original equation, 15 minus 1 is 14. The absolute value of 14, hey look, it's 14. Negative 13, let's plug that in. Negative 13 minus 1 is negative 14. The absolute value of negative 14 is positive 14, so it still works. So both of these are true answers. Okay, so we know we got it right. All right, last one, number 10. This one is where we we might have an extraneous solution because I have an x on this side. But our first step is already done. My absolute value is by itself on one side of the equation. So all I have to do is split it up into two separate equations. And we're going to split this up into 3x plus 2 equals positive 4x plus 5. Or 3x plus 2 equals negative 4x plus 5. Now you'll notice something over here. I put a parentheses because it isn't 4x that's negative, it's this whole side that's negative. So we had to put a parentheses to remind myself that that negative applies to that whole side, so I have to distribute that negative before we can solve. All right, let's try this out. I'm going to solve this side first. I'm going to subtract 3x to both sides. And I'm going to subtract 5 to both sides. So 2 minus 5 is negative 3. 4x minus 3x is 1x. So one of my solutions is x equals negative 3. Okay, now for my other solution over here. We're going to start off by distributing this negative. So we're going to have a negative 4x minus 5 equals 3x plus 2. And so we can go about solving in a similar way. Let's go ahead and add 4x to both sides. Let's minus 2 to both sides. And so we're going to have a 7x equals negative 7. Divide both sides by 7. So x equals negative 1. So here are my two answers, but we still need to check and see if any of them are extraneous. I'm going to start with this negative 3, and I'm going to check this and see if it's extraneous. So I'm going to go absolute value of 3 times, we're going to plug in that negative 3 in for x. 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. Well, 3 times negative 3 is negative 9. Negative 9 plus 2 is negative 7. All right, let's try the other side. 4 times negative 3 is negative 12. Negative 12 plus 5 is negative 7. Well, does the absolute value of negative 7 equal negative 7? No, it equals positive 7. So this doesn't work. So this answer is a extraneous solution. Okay? So it doesn't actually work. Well, what about this one? We can try this one as well. X equals negative 1. Let's plug that back into my original equation. We can go 3 times negative 1 plus 2 equals 4x plus 5. Okay, 3 times negative 1 is negative 3. Negative 3 plus 2 is absolute value of negative 1. 4 times negative 1, forgot to write that in there. 4 times a negative 1 is negative 4. Negative 4 plus 5 is a positive 1. Does the absolute value of negative 1 equal positive 1? Yes, because it's just going to be 1. So it's 1 equals 1. Hey, look, here is my only answer. So long story short, you can have two answers, you can have one answer, or you can have no solution. But you still follow the steps the same. Last one. This is just a little practice with a little f of x. It's just asking us if f of x equals x squared minus 5, what is f of negative 4? Guys, all this means is you take what is here, plug it in for x, and see what it is. That's all it's saying. So let's plug in negative 4 for x. So we'll go absolute value of negative 4 squared minus 5. Well, negative 4 squared is 16. 16 minus 5 is 11. The absolute value of 11 is 11. All right? Listen, that was just kind of the side thing. The main thing I want you to think about is how to solve these absolute value equations. And if you ever see just f of a number, that just means plug it in for x and see what it is. That's all it means. All right. Remember, the notes are on Google Classroom. All right. I will be in class or on Google Meet to help you as much as I can. Please let me know of any questions you have. And I hope we have a great start to our second unit.